Welcome, 6th grade. Today, we figure out how to find the area of parallelograms, all right? What is the perimeter of a square with lengths of 15? Now, we have to think a square has 4 sides, 15 on each. If I was to walk around the whole square, 15, 15, 15, 15, that's 4 of them, so it's 60. A rectangle with 16 and 11. Many of you made this mistake because I don't know, you didn't think. All right, we had 16 and 11, we get 27. Oh, that must be the perimeter. Those are the only two numbers they gave us. But you have to think about a rectangle. If this side is 16 and this side is 11, this side is 11, this side is 16. Got to go all the way around. You just saw I'm going to get done fast and didn't think. It should not be 27, but 54. You guys are smart, but you do have to take your time, which is hard in these days where it's so nice, I understand. All right. Today we're going to estimate the area of irregular shapes and find the area of rectangles and parallelograms. So, area. The area of a figure is the amount of surface it covers. We measure area in square units. So, if this is 1 inch by 1 inch, that's 1 square inch. That's how we're measuring things, okay? When we look at this, you see the grid that they put there? Each of these is equal to 1 square mile. So if we count all the red ones, that's the full ones. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 square miles. 1 mile by 1 mile on each of those sides. So 19 square miles that are full. And then we'll have to look at the partial ones. All right, the blue are ones that are about half. We count those. The green ones are about half. We count those. There are 4 of them, so there's 2. We count the almost full ones. There's 9 of those. And then since we counted the almost full ones, we don't count the almost empty ones, and it should balance out. Now when we add the 19 full ones, the 9 blue ones, which we counted as 1, and then there were 4 that were green and half of a square, well, 2 halves make a whole, so that'd be 2. We get 30. All right, we look again here. We count the full ones, the 1 square by 1 square. This is literally what we're doing. How many of these 1 square by 1 square or 1 by 1 squares will fit on a shape? So when we do this, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, 11 red squares. Almost full ones are the green ones this time. All right, 1, 2, 3, 4, 5, 6, 5, excuse me. All right, then there's 4 ones that are like half. They're the blue ones. So 4 halves makes 1, 2 wholes. All right, do not count the empty ones, which would be the yellow ones. All right, 11 plus 5 plus 2 is 18, and that's about how many squares that covers. Okay, now, the area for a rectangle is length times width. If this one's 4 long, 3 wide, 4 times 3 gets us 12. That's the area. That's how many squares it take to cover that figure that is 4 by 3. So when we look at this, 15 times 9, because that's length times width, 15 times 9 is 135. Now when we did that, we also took inches times inches, because 15 inches, 9 inches, we want to simplify that and write it too. So another way to simplify it is saying inches squared, which should say inches by inches. So 135 inches squared. Since we took the inches times the inches, that's another way or a new way to condense that and write it down. That's where you get the squared from for area, because you take 2 different measurements and you take them times each other. Inch times inch, another way to write that is inches squared. Okay? The other thing that I do want to show you with this, if I were to take and divide this into 15 1-inch strips, and 14. Those should be even, and then I'd take this and divide it into 9. if I would count all those squares, and they should be even, I'm freehanding it, there'd be 135 squares in there. 1 inch by 1 inch squares. This is obviously not to scale, but that is literally what we're trying to find out. How many 1 inch by 1 inch squares will fit in this shape? All right, they're gonna say put it in the formula. Formula is area of the length times the width. We substitute 15 times 9, 135. Don't forget about the inches squared. This one, 13 times 17. No, 13 times 7, my apologies. And both of them have inches. So it's really saying inches times inches. Well, inches times inches is inches squared. Remember, we're writing it like that to help conserve space. All right, so that's 91 inches squared. Now, if you don't trust me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 13 rows there. 1, 2, 3, 4, 5, 6. There's 7 rows there. If we count all those, there would be 91 squares. That is literally what we're trying to figure out. How many square 1 inch by 1 inch pieces will fit in there? All right, and the shortcut way of doing that is taking the length times the width. Here's the formula, length times width, 13 times 7, 91. Okay. Now, you can use the formula for area of the rectangle to write a formula for the area of a parallelogram. This is a parallelogram, 2 parallel sides, all right? The important stuff for us is the height. The height is the width, if you notice, and the base. Because if we take this triangle and put it over here, on this side of it, do you see how it makes a square? What they've literally done over there is taken this and moved it here. Made a square, excuse me, a rectangle, my apologies. All right, so we take height. Whatever this slant is, that doesn't matter unless we're doing perimeter. The height, a 90 and straight up to the top is what matters. And the formula that's new, they're gonna say base times height, which is really just saying length times width, okay? But the width is the height and the base is the length. So let's try it out. So we see 1 1/4 is the height, 2 1/2 is the feet, and we're trying to figure out how many squares will fit in there. So if we take and get 5/4, and we take that times 5/2, I've just turned each of these into improper fractions. That's all I did. All right, we get 25 over 8. That should say 25. Okay, when I take that back, then I would get 3 1/8. And we took feet times feet, so we would now have, hopefully you know it's feet squared, and we get our answer. Feet squared, okay? I love that they use fractions. We get to practice with that a little bit. I'm sure you do too. All right. All right, so there, they turned them into mixed numbers. They multiplied 25 eighths, or 3 1/8 feet squared. Here again, notice, straight line from the top to the bottom, that is your height, this is your base, all right? 7/2 times 3/2, we get 21 over 4. All right, I will reduce that back down to, or take it back to a mixed number, 5 1/4. And don't forget, we had feet and we had feet, so that would be feet squared. Because if we took these, it's like saying feet here, feet here. Oh, 2 feet, that's feet squared. That's why we're always having squares for that. All right, so write the formula. We put those items in there. We multiply, and we get our answer. Now, Draw a picture. Draw a picture. Please, draw a picture. Jessica is going to tile a kitchen that measures 13 feet by 17 feet. So I have a rectangle. 13 feet by 17 feet. Some of the floor space is taken up by an island that measures 3 feet by 6 feet. 3 feet by 6 feet. How much area remains to be tiled? Question, do we have to put tile under this island? No, we wouldn't have to. So now, how do we figure out all this other area? Well, I know how to figure out 17 times 13. So 1, there's 51, 7, 1. All right, that's a 1, 12. 221 is the whole kitchen, but that includes the part under there. Oh, this is 3 times 6, that's 18. Well, that takes up 18 of the feet. So what do I do if I want to figure out what is not covered by that? I would use these two numbers and I would subtract, and I should get 203 feet, and since their area, it's squared, that need to be tiled, okay? Oh, to go figure all that out, if I figure out the total, subtract what was there in that little one, we'd be good to go. All right, let's erase and let's see what these guys did. Get a look at it from their nice, pretty drawings instead of my hand-drawn ones. Okay? So, find the area. So, floor area minus island equals kitchen to be tiled. All right? 13 times 7 was the whole thing. 3 times 6 was the island. We subtract those. 221 minus 18 is 203 feet squared. All right, let's look at it again. Miguel is going to landscape his backyard that measures 16 feet by 11 feet. So, 16 feet by 11 feet. All right. Some of the backyard space is taken up by a built-in barbecue that measures 2 feet by 4 feet. I like to put barbecue grills in the corner, so that's what I'm going to do. 4 feet by 2 feet. How do I figure out how much area needs to be landscaped? Hopefully we'd say, oh, find the area, 16 and 11. 16 times 11, that is going to be, oh, let's do the math real quick. 6 and 1, 6 and 1. All right, that would be, all right, 6 and 1, 6 and 1. 171. Oh, so when I take 16 times 11, I get 171 feet squared. Minus that part that was taken up by this barbecue grill, this area here. I don't need to landscape that because there's a grill there. That's 2 times 4, which is 8. 171 minus 8 would be 163, and don't forget our units, feet squared. We'd have our answer. All right, let's see what they did, ladies and gentlemen. Okay. 176 minus the 8. Oh, I wrote it wrong. So it's going to be actually a different number than I came up with. It'll be 168. 168 feet squared. Because we take the area we have minus that part taken up by the barbecue grill. All right. You're ready to go? Area of parallelograms and rectangles. Not so bad.